welcome to Test 2 Review, questions 14 through 17. I'm going to do them together because they all are related to the same question. Okay, questions 14 through 17. A baseball with a mass of 2 kilograms. Assume now that the baseball has that mass, but in reality it is lighter than that. The baseball is moving with a speed of 20 meters per second and is stopped by the catcher's mitt. So the pitcher throws the ball, let's say, 20 meters per second, which is actually kind of slow, but again, assume that this is a realistic speed. So then the catcher catches that, the baseball hits the mitt, and it takes 0.5 seconds for the ball to come to stop in the catcher's mitt. 14, what is the impulse imparted to the baseball? What is the impulse imparted to the baseball? The units of that is kilogram meter per second or Newton seconds. So the choices is 40, 80, 20, 2, and 1. Question 15, what is the force exerted on the baseball during that time interval? So the choices are the same, 40, 80, 22, and 1. So how are we going to do this? Then I'll write down questions 15 and 16 and 17. So let's erase some of this. Okay. So how do we find the impulse? Impulse, whose symbol is J, is defined as the force times delta T. Basically, impulse is the product of how much force you exert on something times the time interval that you are in contact with it. And it can be shown that impulse is the change in momentum of an object. P is the symbol for momentum, and J is the symbol for impulse. Okay? So what is the impulse imparted to this object? Well, we don't know the force yet, but we do know the change in momentum. Momentum is what? Mass times velocity, right? So if I want to know the magnitude of the impulse imparted on the object, I do mass times final velocity minus mass times initial velocity. And right now, all I'm interested in is the magnitude of that. The mass of the baseball times its final velocity minus the mass of the baseball times its initial velocity. That's the change in momentum. Okay? So what was the mass of the baseball is 2 kilogram. Okay? So the mass of the baseball is 2 kilogram. The final velocity is 0 minus the mass of the baseball is 2 kilogram. The initial velocity was 20. Take the absolute value of that. Again, I'm just interested in the magnitude. Well, since the final velocity was 0, this disappears. 2 times 20 is 40, right? So absolute value of negative 40 gives you 40. So the units of it is what? Kilogram meter per second. So the answer is what? A, right? For the what is the impulse? Question 15 says, what is the force exerted on the baseball during that time interval? Well, force times the time of contact between the object is equal to the change in momentum, right? So how do we get that? Well, we know that the force times the delta T is the change in momentum. So we don't know the force. We know the time of contact is a half a second, right? And what's the change in momentum? Well, we already found the change in momentum was 40, which is the same thing as the impulse, right? 40. So what is the force of contact? The shorter the time of contact, the bigger the force of contact, right? So the reason why the mitt helps you catch a ball is because it makes the delta T larger, right? By increasing the time of contact between the ball and your hand, and the time that it takes for the ball to stop, it decreases the force of contact, right? So force 40 over a half, that's going to be 80, right? What if you had tried to catch it with your bare hands? Okay, it hits your hand. Well, the time of contact might have been 0.1 seconds, right? So it would have been 0.1 times 40. What would the force have been then? 40 divided by 0.1, it would have been 400 newtons, right? So that would have really hurt your hand if you tried to catch a baseball with your bare hands. So the mitt extends the time of contact and decreases the force. So the force is 80 newtons, and The answer therefore is what? B, 80 newtons. Now the next question, which are related to this, number 16 says, who experiences the greatest impulse? So let's write this down quickly. Who experiences the greatest impulse? Who experiences the greatest impulse? Choice A says the baseball. Choice B says the catcher. And then choice C says it's the same. They experience the same impulse. Choice C says the same. So what's the answer to this one? Think about it a second. Who experiences the greatest impulse? Notice it's not saying who experiences the greatest force. It's saying who experiences the greatest impulse, right? So who experiences the greatest impulse? They both do, okay? As a matter of fact, even if it said who experiences the greatest force, the answer would again be they both do the same force, okay? Action and reaction. Remember Newton's third law. One object hits another object, the other object hits the other object back, the force is the same. The time of contact is also the same. If the baseball is in contact with the mitt for 0.5 seconds, the mitt is also in contact with the baseball for 0.5 seconds. So the impulse should be the same, right? So delta J is equal to F delta T, right? Since the force and the delta T is the same, that means the J is the same. The J is the same for both objects. So the choice should be C. They both experience the same impulse. They both experience the same force. Question 17 says, who experiences the greatest change in momentum? Okay, so let's write that down. Who experiences the greatest change in momentum? Who experiences the greatest change in momentum? The choices are the same. So baseball, C catcher, B catcher, and C the same. Now, the unsuspecting person, okay, of course, is going to look at this and say, okay, impulse is force times delta T, and impulse is equal to change in momentum, right? Therefore, if they experience the same impulse, and of course, then they're going to experience the same change in momentum, right? So, the unsuspecting person is going to say the same, okay? But there's a little bit of a trick here, okay? It was a little bit trickier than that. When the ball is coming, right? And then here's the catcher with the mitt in their hand, okay? Let's say it's like that, with their legs like this, kneeling down, okay? So basically, the catcher is catching the ball, right? The ball is coming with a certain momentum. The final momentum of the ball is what? Stops, right? The initial momentum of the catcher is 0. When he catches the ball, he's still stopped, okay? Unless, of course, he falls backward or whatever, but we're assuming he is still stopped, he catches the ball. So the initial momentum of the person is 0, the final momentum of the person is 0. The catcher exerts an impulse on the ball. The ball in return exerts a force on the catcher. They both exert force on each other. Their impulse is the same, but not their change in momentum. The ball loses its momentum. The person does not gain any momentum. Why is that? Why aren't they experiencing the same change in momentum? Well, because the person has their foot planted on the ground. The ground exerts an external friction force, right, on the person and balances out the force of the baseball, right? So if there was no ground friction, of course, then the ball would go hit the person together, they would go backward, right? Together as a system, if it was on a frictionless ice. But since he's on the ground, the friction force enables him to stand still, so that acts as external force. So therefore, this equation, impulse is change in momentum, is only true if there are no external objects exerting a force. If there are no external objects that are causing an external impulse, right? If they cause an external impulse, then they can cancel your own impulse, right? So this only assumes that there's no external forces. So because of that, who experiences the greatest change in momentum? The baseball. The baseball's momentum goes from being something to being nothing. The person's momentum stays the same. So the answer is baseball. Okay, let's go to the next question.